As you can see, generally both DC currents and voltages are produced by the power supplies, batteries, and solar cells, to name a few. So, so DC voltage or current has a fixed magnitude amplitude. So you can see, if you open a paint like this, so you can see this is a DC current coming through, which is a -5 to the highest is 5, and this is the curve it takes. So it's like a sinusoidal wave, -5 to 5, and this is a 12 volts, which shows it's in the positive direction. So you can see it's going in a unidirectional. So if you do voltage divided by R, which is I think this thing, R I think represents this capacitor or this resistor. I think resistor, yeah. Voltage divided, so you can see the I current is unidirectional current. When it's going like this, unidirectional current going on, and basically you have AC, you have a AT equals A max times sine of 2 pi ft. So you can see this thing right here, that this 2 pi ft, what it does, it takes the A, which is the current, and you multiply it by the max of it. So this is the max, A max. You multiply it by the sinusoidal wave. So basically that gives you an A, which is mathematically it is AC current. So this is a AC current, and you have AC waveforms coming in, and so basically what you have is a periodic waveform. So it's a periodic waveform with a voltage and a current. So the AC waveform is periodic because it has a particular period, so that makes it periodic. And you can do like frequency, so you can calculate the frequency of it by going 1 over the time, which is hertz. Frequency is coming, A is the amplitude, so this is the whole x and y axis, and this is positive 5, this is -5, so the amplitude is this thing on the x-axis. And basically, yeah, so that's a sinusoidal waveform. It comes in different ways also. Sometimes you might see it triangular, sometimes you might see it like this, X form, and so these are basically cycles. So you have a cycle going on, and the time taken by the waveform to complete one full cycle is called a periodic time. So this is the frequency, and that's what it is. So you have a periodic time 1 over t. You have a 1 over f thing going on, which is the frequency, and you get this thing. So periodic time is 1 over f is 0.2 seconds. So you can figure out what is the periodic time. So if it's a 50 hertz waveform and it's 2, the frequency is 1 over 50, which is 20 milliseconds. Frequency is 100 megahertz. calculate the frequency and that, and you can also get the waveform in kilohertz and megahertz and gigahertz. Kilohertz, megahertz, and gigahertz. Amplitude, which is the maximum peak, the Vmax and the Imax, which is the current, and calculated by the Ohm's law, and you have a plus and minus voltage going on, and you have a sinusoidal positive peak, and all that's going on. Then you have the RMS value of the waveform, which is root mean squared, which is I square. I is the thing, and R is the resistance, and I is the the thing coming in, the current. I think it could be the current. And to figure out the RMS value, you can multiply 2 pi times Vmax, which is Vmax times this. So that's 0.707 times Vmax, 0.637 times Vmax, like that. Sinusoidal wave. Then you have an electromagnetic induction, which is the EMF thing, and sinusoidal waveforms going on, and you have a magnetic pole, you have a magnetic flux in the middle, rotation is happening, you have this EMF in the loop going on 180, and you can calculate the hertz, which is the frequency, which is 1 over 60 hertz. So then you have the instantaneous voltage, which is the the AC waveform through the magnetic field, and you have this Vmax times sine of theta. So this gives you the displacement of the coil. So you have 2 pi radius, which is 2 pi, and 6.284 times 2 pi, which is this 360 times 2 divided by 2 pi, 57 degrees Celsius. So you can figure out the Celsius of that. 30 divided by 80. You can get radians and degrees and all those. Sinusoidal waves is an alternate quality that can be presented. We see, pi over 2, 3 pi over 2, pi and 2 pi. Phase differences, going on over here, 2 pi radians. This is the phase difference. Cosine WT is sine of plus theta. Wave relationship, you can see it's going from negative pi over 2 to cosine to down, and 3 pi over 2 sine and 2 pi over 2. Then we have the phasors, which is lag and V and 0, and we have AT equals AM sine of WT plus theta, which is this. You can go clockwise or anti-clockwise. Peak, you can get W is 2 pi F, which is the direction of the thing, phase difference. So if you need more information, you can always message us, or you can so thank you for talking to Chris Soft, and if you have any specific questions, please free to send us in the YouTube channel, and as always, have a nice one.